Okay, the airbag carrier is actually removable, so it can be fitted in and then inserted into the machine. That's now in situ. There's the Arduino is running at the moment because it's plugged into the USB feed, but to operate it, switch it on. It will then this is what I've got to sort out with this. You know, it's got to be on a stop so it doesn't do this. But if I reset it, reset the system, it will start to initialise, and then it should come back to the limit switch, and then it's gone to a 0 point. It's now started stroke. Now with the stroke at the moment it's on maximum and it's on the longest delay, so once that does its next stroke we'll get the first set of readings. And I haven't got the I haven't got the mask connected to the bag. Hang on, let's pop that onto there. Get us to get that seal on there. What I've done is I've just put it in the tube from the sensor into the mask, just with a bit of back pressure there, so we can start to see some readings. I'll get it right. There we are. So it's showing 16.57 centimetres of water, which is somewhere near, if my calculations are right, but it's worth having a second look at. Then we can, from the controls, I can reduce the rate, the repeating of the, so it'll repeat faster now on each stroke. Just wait for it to finish this last cycle, that'll be into the new cycle, and you'll see the rate's now changed to 8, so it's twice as quick as it was. And then on this one here I can actually control the volume, which is the stroke of the machine. And you'll see that the output then will change here from 6 to 10. So by varying the rate and speed, we control the amount of respiratory rate and the volume of air going in, and that's showing about 15, so there's a pressure building up, but because I haven't got a proper seal on here, we're obviously losing back pressure. But to just give you an idea, so the electronics is the secret to it. And I've sort of cobbled it together from bits of other people's code and trying to work, but I've used the sensor, which obviously will go into the pipeline at some point, but trying to this will actually needs to be calibrated correctly, and I probably need to get a manometer, water manometer to check to see what the readings are exactly. Alright, it's just to give you an idea of what we're doing, and all these parts, I mean this is just temporarily mounted here to test the system, but it'll be fixed in permanently, and we're basically using 3D printer parts, 12 volt power supply, the driver is the TB660, which is what, and it's a NEMA 17 stepper motor in here, which is actually a 24 volt, but it's running off this 12 volt, and we don't get any temperature warmth, although I have got the fan, but that may not necessarily be required now, but I'll leave it there until I've housed it and make sure we don't overheat. So the idea is to actually encase all this up to here in a perspex container with base and everything, and then make a better job of it. But for prototyping and testing and working out the circuitry, this is and I've had it running for 5 days continuous at a fairly rapid rate, just to stress test the parts, and it's proving to be very, very reliable. It's just the electronics are sort of getting there, but it needs finalising. Hope this gives you a bit of an idea. I've sent you some drawings with the schematics of this electronics. This arrived today, and I added this in, and added some code in, mucking about with the INO file, and I've got it working of sorts, but it really needs somebody to have a look through. But you know, I may have some of the readings here. They should be being presented earlier than right at the end of the cycle, but I don't know. It may be something the way I've got it laid out within the INO file. Hope that explains a bit. Any questions? Give us a shout back, and thanks very much for your input. It's appreciated.